The crystalline plates along Exertic's back shimmered with nervous energy as they stepped through the quantum-stabilized gateway onto Earth's first Galactic Exchange Academy. Their sensory appendages tingled at the sudden change in atmospheric composition. The air here was thicker, heavier with nitrogen and oxygen than their home world's carefully regulated environment. The central atrium of the academy stretched upward in sweeping curves of transparent aluminum and polished stone, designed to accommodate species of all sizes and atmospheric requirements. Floating signs in multiple languages, including the standard galactic pictographs, directed various beings toward their designated orientation areas. "Welcome, Junior Xenobiologist Exertic," a warm voice called out. The crystalline being turned to find a human approaching them, and their sensor crystals immediately began recording data. The human's outer layer was a rich brown color, smooth and flexible in a way that seemed to defy proper protection protocols. "I'm Instructor Sarah Chen. I'll be your primary contact during your research. Stay with us." Exertic's translation crystal hummed to life. "Gratitude for the welcome, Instructor Chen. Your facility's architecture exceeds preliminary data expectations." They paused, careful to modulate their harmonics to convey respect rather than the fascination they felt watching the human's outer layer shift and move with each gesture. A group of gaseous beings drifted past, their containment fields shimmering with patterns that indicated excitement. Behind them, a silicon-based student whose crystalline structure was quite different from Exertic's own moved with careful precision, their gravitational adjusters whirring softly. "Please, follow me to the Xenobiology department," Sarah said, gesturing with one of her remarkably flexible upper appendages. "We've prepared a specialized observation chamber for your research." As they walked, Exertic couldn't help but notice how the human's outer covering responded to environmental changes. When they passed through a patch of sunlight streaming through the atrium's windows, small bumps appeared on the instructor's exposed arms, a phenomenon that sent Exertic's sensors into overdrive. "Instructor," they ventured, their crystals vibrating with curiosity. "Your protective layer appears to be responding to solar radiation. Is this a defense mechanism?" Sarah laughed, a sound that made her entire form shake slightly. "Those are just goosebumps, a temporary reaction to temperature change. Human skin is quite responsive to environmental conditions." Exertic filed this information away, their data crystals thrumming with excitement. Their thesis advisor back home had suggested that studying soft-bodied species would be less enlightening than researching silicon-based life forms, but already they were discovering fascinating adaptations. The Xenobiology lab proved to be a marvel of adaptive architecture. Sections were partitioned with various atmospheric barriers, allowing multiple species to conduct research simultaneously. Sarah led them to a workstation equipped with sensors calibrated to crystal-based life forms. "This will be your primary research space," she explained, interfacing with the local computer system. "You'll have access to our database of human biological information, and of course, you can observe my physical education classes, as we discussed in the preliminary communications." Exertic's sensor arrays quivered with anticipation. The concept of physical education remains intriguing. "Among my species, our forms are permanent once we reach maturity. The idea of deliberately stressing one's structure for improvement seems counterintuitive," Sarah suggested, her facial features arranging themselves into what Exertic's cultural database identified as a smile. Indeed, yet the academic board was most interested in how humans maintain functionality despite their seemingly vulnerable construction. Sarah's smile widened. "Well, I think you'll find we're full of surprises. Speaking of which, your first observation session begins in an hour. The students are practicing something called yoga today. It's quite a demonstration of human flexibility." Crystals chimed with enthusiasm as they began calibrating their sensors. Their first day was already proving far more fascinating than expected, and they hadn't even begun their formal observations. Perhaps their thesis advisor had been wrong about soft-bodied species after all. The anti-gravity gymnasium hummed with energy fields as Turtik positioned their sensor arrays at the observation station. 3 standard Earth weeks had passed since their arrival, and they had grown accustomed to the strange sight of humans moving their malleable forms through various exercise routines. Today, however, was different. The ambient temperature had risen significantly due to a minor malfunction in the environmental controls. "All right, everyone," Sarah called out to her class, her voice echoing through the spacious chamber. "The maintenance team is working on the cooling system. We'll modify today's exercises to accommodate the heat." Turtik's data crystals recorded the humans removing their outer protective layers, a process that still fascinated them, revealing the base layer coverings humans called workout clothes. The crystalline being had learned that humans maintained multiple layers of artificial protection to compensate for their lack of natural armor. As the class progressed through their low-gravity agility exercises, Turtik's sensors detected an anomaly. The human's outer covering was changing color, shifting from various shades of brown and beige to reddish tints. More alarmingly, their temperature readings were elevating beyond previously recorded norms. "Instructor Chen," Turtik called out, their harmonics pitched with concern. The students appeared to be experiencing widespread chromatic shifts and thermal irregularities. Sarah wiped moisture from her forehead, another fascinating human cooling mechanism, and smiled. "That's normal, Turtik. We're just getting a bit sunburned from the UV lights. They're running higher than usual with the system malfunction." But Turtik's concerns only grew as the class continued. Their enhanced visual sensors now detected something unprecedented, microscopic particles of human outer layer appearing to separate and lift away. The phenomenon was spreading across multiple subjects simultaneously. The other alien observers had noticed too. A gaseous student named Svex was pulsing with patterns of distress, while Silicon observer Critex had backed away from their observation post, their crystalline structure vibrating at frequencies associated with alarm. "Emergency protocols must be initiated," Turtik announced, their crystals flashing warning patterns. "Multiple subjects are experiencing simultaneous outer layer degradation. The structural integrity of their protective covering appears to be failing." The gymnasium erupted into chaos. The emergency containment fields activated automatically in response to Turtik's alert, bathing the room in a soft blue glow. Other alien observers began implementing their species' respective emergency responses. The gaseous beings formed a swirling pattern of distress, while the silicon-based observers emitted high-frequency warning tones. Sarah, who had been spotting a student in a low-gravity somersault, landed gracefully and raised her hands. "Everyone, please remain calm. There's no emergency." But Turtik was already accessing the facility's medical database. "Humans are experiencing mass epidermal degradation. According to my readings, the phenomenon is spreading rapidly across all exposed surfaces." The human students, now floating gently in the containment field, looked at each other in confusion before starting to laugh. The sound echoed strangely through the emergency force fields, creating an unusual harmony with the various alien distress signals still filling the air. "Turtik," Sarah said, trying to suppress her own laughter as she maneuvered through the anti-gravity field toward the observation station. "We're just peeling from the sunburn. It's a natural process. Our skin renews itself regularly." The crystalline being's sensors whirred in disbelief. Intentional shedding of protective layers, without replacement structures already in place. The biological implications are. Their speech was interrupted by a small piece of skin floating past their sensor array. A student had absent-mindedly peeled a bit from their arm. Turtik's crystalline structure vibrated at a frequency that their species used to indicate extreme scientific excitement mixed with horror. "Fascinating," they chimed, all their sensor arrays focusing on the drifting specimen. "But how do you maintain structural integrity during the replacement process? The vulnerability window must be significant." Sarah realized that this impromptu demonstration of human biology was about to turn into something much more interesting than her planned lesson on zero-gravity athletics. The emergency containment field hummed softly as they powered down, leaving a room full of floating humans and agitated alien observers. Sarah Chen activated the classroom's holographic display system while attempting to smooth down her hair, which was still drifting slightly in the lingering anti-gravity field. "Perhaps," she said, addressing the assembled xenobiology students, "this is the perfect opportunity for an impromptu lesson on human dermal regeneration." Certic's sensor arrays reoriented themselves toward the display, their crystalline structure still vibrating with scientific excitement. The gaseous students Sphext had condensed into their most concentrated learning form, while the silicon-based observers had arranged themselves into a traditional academic lattice formation. "Computer," Sarah commanded, "display microscopic cross-section of human skin structure with regeneration cycle visualization." The air filled with a giant three-dimensional model of human skin layers. Several alien students drifted backward as they saw the complexity of what they had previously assumed to be a simple protective covering. "As you can see," Sarah began, highlighting the outer layer, "human skin is actually a complex organ composed of multiple layers. What you're witnessing with our current peeling situation is the natural shedding of damaged epidermal cells." Certic's translation crystal worked overtime as they recorded every detail. "But Instructor Chen, how do you maintain barrier integrity during cellular replacement? Our species requires complete structural stability at all times." Sarah zoomed in on the skin's basal layer. "That's the fascinating part. Our skin cells are constantly regenerating from the bottom up. New cells are created in this basal layer, gradually moving upward as they mature. By the time the outer cells shed, the replacement layers are already in place." A human student demonstrated by peeling a small piece of sunburned skin from their arm, causing several silicon-based observers to chime in distress. The piece floated through the air until Sarah caught it and placed it under a molecular scanner. "Observe," she said, as the scanner's image appeared beside the holographic model. "These cells have already been replaced. What you're seeing is essentially biological scaffolding that's no longer needed." Sphex pulsed with patterns indicating deep thought. Query: "Does this rapid regeneration apply to all human tissue types?" "To varying degrees, yes," Sarah replied, expanding the holographic display to show different healing processes. "Our bodies are in a constant state of renewal. Skin cells typically regenerate every few weeks, while other tissues have different timeframes." Certic's data crystals were practically singing with new information. "The implications for adaptive evolution are extraordinary. Your species can potentially modify its protective layer in response to environmental changes within a single generation." The human students, still floating near the ceiling, had begun to show off their peeling skin with theatrical flair, much to the mixed horror and fascination of their alien classmates. One student created a small collection of shed skin pieces that spelled out "hello" in standard Galactic script, earning both groans and appreciative chimes from the audience. However, Sarah continued, trying to maintain academic decorum despite the increasingly playful atmosphere, "This regenerative process doesn't mean we're invulnerable. The redness you observed is actually a mild form of radiation damage from the elevated UV levels." She gestured to her own reddened arms. "Our skin produces additional melanin, a protective pigment, in response to UV exposure. The peeling you're witnessing is our body's way of removing damaged cells, while the deeper protected layers maintain structural integrity." Certic's sensor arrays suddenly focused on a particular data point. "Instructor Chen, are you suggesting that human outer layers actively respond to and adapt against environmental threats?" "Exactly," Sarah beamed. "Our skin is a dynamic organ that—" She was interrupted by a sudden chiming from Certic's direction, the equivalent of a crystalline gasp. The junior xenobiologist's data crystals were flashing in patterns that indicated intense calculation and correlation of data points. I believe, Exertic announced, their harmonics vibrating with barely contained excitement. This process may have significant implications for solving our species' crystalline degradation issues. The classroom fell silent, even the floating human students pausing their skin-shedding demonstrations. Sarah recognized the tone in Exertic's harmonics. It was the sound of scientific breakthrough about to unfold. The Academy's crystalline research laboratory glowed with soft blue light as Exertic reviewed their holographic data displays for the 20th time that night. The excitement from the earlier sunburn incident had made sleep impossible, sending their thoughts spinning with possibilities. Their personal crystal lattice hummed with sustained analytical frequencies as they compared human skin cell regeneration patterns with crystalline growth structures. Computer, display time-lapse comparison. Human epidermal renewal cycle versus standard crystalline repair sequence. Exertic commanded, their translation crystal automatically converting their harmonic speech patterns. Two holographic models materialized in the air before them. On the left, a representation of human skin cells showed the continuous process of regeneration, with new cells pushing upward as older ones shed away. On the right, a crystalline repair sequence demonstrated the current method used by their species, a complete replacement of damaged sections that often left vulnerable gaps in their protective plates. The fundamental difference, Exertic muttered, their sensors focusing on the point where new human skin cells began their journey upward, is the continuous nature of their renewal process. We replace, they regenerate. A soft chime announced an incoming communication. The laboratory's door slid open to reveal Sarah Chen, carrying what humans called a coffee cup, another fascinating adaptation that Exertic had noted in their cultural observations. I thought I might find you here, she said, stepping carefully around the delicate crystal growth chambers that lined the walls. The overnight sensors showed your lab was active. Have you been here since the demonstration? Exertic's crystals flickered in what humans had learned to recognize as embarrassment. Time becomes irrelevant when pursuing a promising research direction, Instructor Chen. Observe these comparative models. Sarah moved closer, her eyes widening as she took in the complex data streams flowing across the holographic displays. You're comparing our skin regeneration to your species' crystal repair process. Indeed. Exertic adjusted the display to show a third model. This is the current crisis facing my people. Our crystalline structures develop microfractures from cosmic radiation exposure during space travel. Traditional repairs require complete plate replacement, leaving individuals vulnerable during the process. The new hologram showed a crystalline being similar to Exertic, their protective plates riddled with tiny cracks that spread like webs across the surface. Sarah leaned closer, her scientific curiosity evident. But if we could apply the principles of human cellular regeneration? Exertic's voice harmonics rose with excitement as they overlaid the human skin regeneration pattern onto the crystalline structure model. Instead of replacing entire plates, we could develop a method for continuous, layer-by-layer renewal. Sarah watched as the simulation played out, showing how a modified crystal growth pattern could theoretically maintain structural integrity while gradually replacing damaged sections, like how our new skin cells form under the old ones. Exactly. Exertic's entire crystalline form resonated with enthusiasm. The challenge lies in creating a crystal matrix flexible enough to allow for gradual replacement while maintaining protective capabilities. But your species has demonstrated that constant renewal can be more effective than static protection. They manipulated the holographic controls, bringing up molecular structure diagrams. I've been analyzing the protein structures that guide human cell regeneration. If we could create a crystalline analog. The door chimed again, admitting a silicon-based student who immediately backed away at the sight of the enthusiastic discussion. Apologies for the interruption, they chimed, but the morning classes begin in 10 minutes. Sarah laughed, checking her watch. Have we really been here all night? Exertic, this is brilliant work, but maybe you should rest your crystals for a few hours. But Exertic was already adjusting the molecular models, their sensor arrays glowing with inspiration. Rest can wait. Instructor Chen, I believe I'm approaching a viable prototype design for a self-renewing crystal matrix. The implications for both our species. They paused as their calculations produced an unexpected result. The holographic display flickered, then stabilized to show something entirely new. A hybrid structure that combined the flexibility of organic regeneration with the strength of crystalline architecture. Sarah stared at the rotating model, her coffee forgotten in her hand. Exertic, she breathed. I think you might have just revolutionized xenobiological engineering. The Academy's cafeteria buzzed with its usual afternoon activity as Sarah Chen made her way through the crowd of various species enjoying their midday nutrient intake. She had just received several unusual reports from the custodial staff and was searching for one particular crystalline xenobiologist. She found Exertic in their usual spot, surrounded by collection vials and scanning equipment, intently studying the group of human students who were trying to eat their lunches while pretending not to notice the excited alien researcher. Exertic, Sarah called out, careful to modulate her voice to avoid disrupting their sensitive crystal structure. Do you have a moment to discuss your recent research methods? The crystalline being's sensor arrays swiveled toward her, glowing with enthusiasm. Instructor Chen, your timing is optimal. I've just collected fascinating samples of varying thickness from different environmental conditions. Observe. They held up a vial containing what appeared to be. Is that skin from the men's locker room floor? Sarah asked, trying to maintain her professional composure. Indeed, the elevated humidity creates a unique preservation environment, and the samples from the swimming facility show intriguing variations in cellular structure, though the maintenance staff seemed unusually resistant to my collection efforts. Several nearby alien students had stopped their meals to watch the exchange. A gaseous being rippled with what might have been amusement, while the silicon-based student's crystalline structure vibrated in frequencies suggesting second-hand embarrassment. About that, Sarah said, pulling up a chair. We need to discuss human cultural protocols regarding biological material collection. Exertic's crystals dimmed slightly. Have I violated preservation parameters? My research documentation indicates all samples were properly sterilized and contained. It's not about the scientific protocols, Sarah explained gently. Humans have certain cultural sensitivities about personal biological materials, even discarded ones. Fascinating. Exertic's data crystals began recording immediately. Is this related to the concept of personal space we discussed during orientation? Though I noted that humans readily shed these materials in public spaces. Their discussion was interrupted by a commotion at the cafeteria entrance. A group of alien students from the biochemistry department had apparently discovered human skincare products. A Jovian gas cluster was attempting to apply moisturizer to their containment field, creating a bizarre prismatic effect, while several silicon-based beings were engaged in an intense discussion about the concept of exfoliation. Please explain. Exertic said, their sensors tracking the chaos with interest. Why humans intentionally accelerate their shedding process with these abrasive substances, yet object to the collection of naturally discarded materials. Sarah watched as a maintenance robot zoomed past, attempting to clean up a trail of spilled moisturizer. It's about consent and privacy. We choose when and how to care for our skin, but we don't want others collecting our shed cells without permission. Ah. Exertic's crystals brightened with understanding. Like how my species regulates access to our molted crystal fragments, though we use them primarily for ceremonial purposes rather than scientific study. Exactly. Sarah smiled, relieved at finding a cultural parallel. Perhaps we could set up a voluntary donation program for your research, with proper protocols and consent forms. Exertic's entire structure hummed with excitement at this suggestion. A formal collection system would allow for better sample categorization and eliminate the need for early morning retrieval missions to the athletic facilities. The custodial staff will be thrilled, Sarah muttered, watching as across the cafeteria, Another alien student discovered the concept of sunscreen and was attempting to explain UV protection to a photosynthetic being. Though I must ask, how certain, their tone shifting to one of scientific curiosity, about the varying elasticity coefficients I observed in the swimming facility samples. Perhaps, Sarah interrupted quickly, we should continue this discussion in the laboratory, after we properly dispose of your current collection. As they left the cafeteria, Sarah couldn't help but smile at the sound of Exertic enthusiastically planning their new, culturally appropriate research protocols. Behind them, the chaos with the skincare products continued to unfold, adding another chapter to the increasingly unusual cultural exchange program. The crystalline research laboratory hummed with an energy that had nothing to do with its standard power systems. Turtic's workstation pulsed with multicolored lights as their latest experiment reached its critical phase. Around them, a small crowd had gathered. Sarah Chen, several alien researchers, and even the Academy's director hovering at the back of the room. Initiating final synthesis sequence, Auric announced, their crystals vibrating at frequencies that betrayed their excitement. The central growth chamber contained a thumbnail-sized crystal matrix, floating in a carefully calibrated energy field. Introducing biomimetic catalyst now. Sarah leaned forward, her eyes fixed on the hovering crystal. After weeks of failed attempts and countless adjustments, they had finally developed a crystalline structure that might be capable of self-repair. The solution had come from an unexpected source: the proteins responsible for organizing new skin cell growth in humans. Structural integrity holding at 98%, reported a silicon-based observer, their own crystals resonating in harmony with the equipment. No signs of lattice degradation. The tiny crystal in the chamber began to glow with a soft, bluish light. Exertic sensor arrays worked overtime, recording every minute change in its structure. They had modified the traditional crystal growth patterns of their species, incorporating principles learned from human skin regeneration. Introducing controlled damage sequence, Exertic announced. A precision laser fired a brief pulse, creating a microscopic crack in the test crystal's surface. The assembled crowd held their breath, or in the case of the gaseous beings, condensed slightly. Previous attempts had resulted in catastrophic crystal failure at this stage. But this time, remarkable, whispered the Academy's director as the crystal's glow intensified around the damaged area. It's actually regenerating. On the molecular scale viewers, they could see the crystal's structure shifting, new growth spreading across the damaged section like frost across a window. Unlike traditional crystalline repair methods, which required complete replacement of damaged sections, this new matrix was repairing itself from within. The basic principle, Exertic explained, their voice harmonics pitched with pride, comes from studying how human skin maintains integrity during cellular replacement. Instead of creating vulnerable gaps during repair, the crystal matrix maintains its protective properties while generating new structure beneath the damaged area. Sarah watched in amazement as the crack sealed itself, leaving no trace of the damage. Just like how our new skin cells form under the old ones, she said, earning an enthusiastic chime from Exertic. Precisely. But the implications extend far beyond simple repair. Exertic adjusted the chamber's controls, bringing up a series of projected applications. This technology could revolutionize crystalline being protection during space travel, enhance the durability of crystal-based technology, and potentially even allow for adaptive responses to environmental changes. The director's crystalline form sparkled with interest. Could this be adapted for larger-scale applications, say, spacecraft hulls or planetary defense shields? The potential applications are significant. Exertic confirmed, their sensor arrays sweeping across the successful experiment. By studying how humans maintain their protective layer through constant renewal rather than static defense, we've discovered a completely new approach to crystal engineering. A junior researcher in the back raised their appendage. But what about the energy requirements for constant renewal? Another lesson from human biology, Exertic responded, bringing up a new diagram. The system operates on a priority basis, focusing repair efforts where they're most needed. Just as human skin allocates resources to heal injuries while maintaining regular renewal cycles. Sarah smiled as she watched her student explain the intricacies of the new technology. What had started as a simple misunderstanding about sunburned skin had led to a breakthrough that could benefit multiple species across the galaxy. There is one minor issue to address, Exertic added, their crystals flickering with what might have been embarrassment. The prototype seems to have developed an unexpected property. When exposed to ultraviolet radiation, perhaps it's easier to demonstrate. They adjusted the chamber settings, bathing the crystal in UV light. The assembled crowd watched in amazement as the test crystal turned a distinct shade of pink. The grand hall of the Galactic Sciences Symposium sparkled with the combined brilliance of 1,000 crystalline beings, their structures reflecting the soft ambient light in a dazzling display. Gaseous entities drifted in their designated observation spheres, while silicon-based scientists arranged themselves in precise geometric patterns denoting their academic status. Certic stood at the presentation platform, their crystals polished to optimal reflectivity for the occasion. Sarah Chen sat in the front row, giving what humans called a thumbs up, a gesture of encouragement that still puzzled most non-human species. Distinguished colleagues, Exertic began, their harmonics carefully modulated to reach all corners of the vast chamber. Today I present a revolutionary breakthrough in crystal engineering, inspired by what many would consider an unlikely source, human skin. A ripple of movement passed through the audience. Several gaseous beings condensed in surprise, while the silicon-based observers shifted their crystalline structures to better capture the data streams. As we all know, our traditional methods of crystal repair have significant limitations. Exertic activated the holographic display, showing familiar images of damaged crystal plates. But through studying human biological processes, we have developed something extraordinary. The central demonstration chamber hummed to life, revealing the latest version of their self-repairing crystal matrix. It was larger now, about the size of a standard data crystal, and glowed with a subtle inner light. Observe, Exertic continued, initiating the damage sequence. A precision laser created a network of cracks across the crystal surface. The audience's collective vibration frequency increased as they watched the crystal begin to heal itself, the damage disappearing like frost melting in sunlight. The key breakthrough came from understanding how human skin maintains structural integrity during cellular replacement. Exertic's sensor arrays swept across the audience, noting the mixture of fascination and disbelief. Rather than replacing entire damaged sections, the crystal matrix generates new growth from within, maintaining protective capabilities throughout the repair process. A senior crystalline scientist raised their appendage. The energy requirements for such continuous renewal must be substantial. An excellent observation, Exertic responded, bringing up their efficiency charts. However, by mimicking human biological systems, we've developed a priority-based repair mechanism that optimizes resource allocation. The system only activates full regeneration protocols when significant damage is detected. Sarah watched with pride as Exertic handled each question with growing confidence. The initial skepticism in the room had given way to genuine scientific interest, especially when they demonstrated the crystal's adaptive properties. And now, Exertic announced, their harmonics taking on a slightly mischievous tone that Sarah had come to recognize, for a rather unexpected feature of our prototype. They activated the ultraviolet emitters, and the test crystal promptly turned a delicate shade of pink. A wave of startled chimes rang through the audience. An unintended but fascinating parallel to human sunburn response. Exertic explained, their crystals flickering with what might have been embarrassment. We're working on adjusting this particular characteristic, though some of our younger researchers have suggested keeping it as a visible warning system for radiation exposure. The presentation concluded with a detailed analysis of potential applications, from spacecraft shielding to personal protection systems. As questions poured in from excited researchers, Sarah noticed several prominent research institutions' representatives making their way toward the stage, their crystal structures vibrating with frequencies that suggested significant funding opportunities. A young silicon-based student approached Sarah after the presentation. Is it true that humans inspired this by actually shedding their outer layer? They asked, their crystalline structure vibrating with curiosity. Sometimes the best scientific breakthroughs come from unexpected places, Sarah replied, watching as Exertic was surrounded by enthusiastic colleagues. Though I never thought my sunburn would lead to a revolution in crystal engineering. The students' crystals chimed with amusement. The galaxy is indeed full of surprises. Though I must ask, does it hurt when humans? They paused, searching for the right words, update their firmware. Sarah's resulting laugh caused several nearby crystalline beings to recalibrate their audio sensors. The sunset painted the Academy's crystalline spires in shades of orange and pink, reminiscent of the now famous color-changing properties of Exertic's invention. In their private research lab, surrounded by holographic displays and data crystals, the young xenobiologist was putting the finishing touches on their thesis presentation. Final draft complete, their translation crystal announced as Exertic's sensor arrays reviewed the document one last time. The thesis, titled Adaptive Crystal Engineering, Lessons from Human Cellular Regeneration, represented months of research, cultural misunderstandings, and breakthrough discoveries. A soft chime announced Sarah Chen's arrival. She carried 2 containers, a coffee for herself and a small vial of mineral solution that Exertic had developed a fondness for during their time on Earth. I thought you might want to celebrate finishing your thesis, she said, placing the vial where Exertic's absorption crystals could easily reach it. Though I have to admit, I never expected my sunburn to end up in a groundbreaking scientific paper. Exertic's crystals flickered with amusement. The universe works in fascinating ways, Instructor Chen. When I first arrived, I believed studying soft-bodied species would be, as my previous advisor suggested, a waste of valuable research time. Their sensor arrays swept across the laboratory, taking in the various experiments and prototypes developed over the past months. In one corner, a maintenance robot worked on integrating the self-repairing crystal technology into its outer shell. Near the window, a rack of test crystals displayed varying shades of pink as they adapted to the setting sun's rays. Speaking of advisors, Sarah said, settling into her specially designed crystal resonance dampening chair, I heard the Crystalline Science Council was quite impressed with your presentation. Indeed, Exertic's structure vibrated with pride. They've approved funding for a new research division focused on bio-inspired crystal engineering. Several other species have expressed interest in collaborative studies. Through the laboratory window, they could see groups of students crossing the academy grounds. A silicon-based being was explaining something to a human student, their crystalline structure shifting to demonstrate a concept. Nearby, a gaseous entity was attempting to participate in a human game of frisbee, using their containment field to catch and throw the disc. Your discovery has done more than advance crystal engineering, Sarah observed. It's helped bridge the gap between silicon-based and carbon-based life forms. Even the most traditional crystalline scientists are starting to see the value in studying biological systems. Exertic adjusted their sensors, focusing on a particular data stream. The latest applications have exceeded our initial projections. The adaptive repair systems are being integrated into deep space exploration vessels, and the medical applications for crystal-based healing technologies show tremendous promise. They paused, their crystals shifting to a frequency that Sarah had learned to recognize as contemplative. Though I must admit, I'm still receiving numerous inquiries about the sunburn mimicking properties. Several younger crystalline beings have specifically requested that feature in their personal protection systems. Sarah laughed, creating the galaxy's first fashion trend in crystal engineering. Not bad for a junior xenobiologist. The council was less amused by that particular development. Exertic chimed, their structure vibrating with hidden mirth. though they did approve my proposal for the new Interspecies Innovation Center here at the Academy. The holographic displays shifted, showing plans for a new wing of the Academy dedicated to collaborative research between different species. The design incorporated elements from various biological and crystalline architectural styles, creating spaces where all forms of life could work together comfortably. From fearing human skin shedding to revolutionizing crystal engineering, Sarah mused. You've come a long way. Exotic. We all have, they responded, their crystals glowing warmly. Though there is one remaining mystery I hope to solve. Oh, yes. Exotic's translation crystal conveyed a tone of genuine puzzlement. Why do humans insist on calling it a peeling sunburn when nothing is actually being peeled? Clearly, it's a controlled cellular discharge process. Sarah's resulting laughter set off harmonic resonances in every crystal in the laboratory, creating an impromptu light show that perfectly captured the spirit of their unlikely friendship and scientific partnership.